My name is Kanika Garg, and I have been in AI and machine learning for past 8 years. I've had experience in machine learning, artificial intelligence, deep learning, and various natural language processing tasks. So today we are going to have a hands-on session on the transfer learning using Keras. So these are the topics that we are going to cover today. The very first is to understand what transfer learning is. How do we do it? What are the requirements for it? Then, of course, we'll code and we'll have some suggestions over the courses. Now, what exactly transfer learning is? Basically, if you try to understand in a very simple language that whatever we have learned, we are transferring it to somewhere. This is what exactly this its English meaning says. So whatever we are doing is we are just reusing our previously learned model on a new problem, like whatever we do in our daily life. Whatever we learn from somewhere, we try to apply to another problem. So if we talk about transfer learning, what exactly we are doing is we are training a deep neural network with a small amount of data. That means we have some pre-trained models available with us, and suppose we have very less data available with us. So no worries, we have a pre-trained model and we can just feed that data to the pre-trained model. It will give the result, voila. So basically, it uses the knowledge that the model has learned already. So with transfer learning, we basically try to use what we have learned in one task to better understand the concepts in another. So weights are being automatically being shifted to a network performing task A from a network that performed new task B. Like we are saying, see, we can see that thing in the image, right? We are just transferring the information, whatever one's brain has, to the another person. Okay. And also, let's just take another example. Suppose me, I want to learn how to ride a scooty. So, and I already know how to ride a bicycle, but I have one friend who has never learned to ride a bicycle. So what do you think? It will be easier for me to learn to ride a scooty, or for my friend? Of course, it would be much easier for me. Why? Because I already has the knowledge about how to balance a two-wheeler. So when it comes to learning a motorcycle or say scooty, it may not be so hard for me as compared to my friend who tend to learn it from the scratch. That is how exactly the transfer learning works. Okay. Of course, here you can see in the diagram itself, without transfer learning, we are providing data set to both the models, and both the models are learning individually. Okay, but with transfer learning, we have the data set that we can work upon with the pre-trained model. So there is a very famous quote that says isolated learning paradigm. What exactly does that means is the current dominant paradigm for machine learning is to run a machine learning algorithm on a given data set to generate a model. So the model is then applied in real life tasks. Okay, we call this paradigm as the isolated learning because it does not consider any other related information or the knowledge learned in the past. So this transfer learning basically trying to resolve this limitation of this isolated learning paradigm, which is a very famous quote. Now, let's understand how transfer learning works. Okay. First, we must understand to train a neural network from a scratch. That means any deep neural network, CNN, RNN, anything. A lot of data is typically required. Okay. But does we have access to that type of data every time? No. So that is when the transfer learning comes handy. Okay. So how it is done? Now, suppose let there be another pre-trained model that can recognize images of, say, dogs and cats. Okay, so more importantly, this model has been trained on a very large image data set. So how can we manipulate so that it can recognize the cars? It is really simple. As you can just see here in example, the last layer is recognizing the breed of the dog. Now what we want is we want this model to recognize the type of the car or the model of the car. So what we are going to do is, all we need to do is to simply delete or maybe remove only the last layer in the network and replace it with the new network, a new layer as shown in the image. Also, the weights, of course, associated with the last layer are reinitialized, and the model is trained using the images of the different cars. Because the initial layers are basically learning the corners, the features of the images like that. So that's it. Now the model will be able to recognize different types of cars. So it is important to note here that instead of replacing the deleted layer with just one layer, we can also add multiple layers if we want to make it learn some more details. Okay. So this is one way of doing it, or we can say this is the simplest way of doing it. Or another way, what we can do is we can just use the pre-trained model as it is and can feed our data just to test it. Okay, if the domains are similar, in that case, we can just use the model and feed our data to test the model and we can get the results. This is how simple transfer learning has made our tasks. Now for today's session, these are the 4 requirements that must be installed in your machine or maybe the Colab. If you're using Colab, so that must be easy. You need not to install them. But if you're doing in your machine, or mean that means Anaconda or maybe Spider or somewhere, then you have to install these libraries. These are the requirements. So now let's see our code. Now here, the code is pre-written because it takes a lot of time to type here right now. So what I have done is I have already run the cells because the later stage that you'll understand that takes a lot of time to process or execute the cells when there is a training part going on. So what we are doing is we are importing our data using read CSV from a site that gives the clickbait data. So it is easily available and freely accessible. Now, if you see, this is the kind of data we have. We have titles and we have labels. So if it says 1, that means it is a clickbait data. And if it says no, 0, then it is not the clickbait data. Now here in this example, we are going to use Keras introduced by TensorFlow 2.0. These are the high-level APIs to build machine learning models, or say the deep learning models. These are combined with the pre-trained models from TensorFlow Hub, and it provides a that simple way for transfer learning in natural language processing to create good models. Now we have our data. What we want is we want to split this data for training and the testing part. So we have imported train and test split, and we just have divided our data into training and the testing frames. Now I just have used TensorFlow Hub that I just explained, that it helps in importing the pre-trained models, and I am using universal sentence encoder here. Okay. So since the goal of this article is to illustrate transfer learning, we have directly loaded the already pre-processed data set into the pandas data frame, and then we finally have taken the pre-trained model called as the universal sentence encoder. It is one of the popular module for generating sentence embeddings. So just for the example to show you, I have used hello world, and to show how the encodings look like, it gives back a 1512 fixed size vector for the text. So it is an example how that we can use TensorFlow Hub to capture the embeddings of the sentence. So it's a smaller example for the hello world, and you can see this has generated this kind of embeddings. All right. So moving on to the next cell. Then I have imported just the TensorFlow, and then we create a sequential model that will encapsulate our layers. Okay. So then afterwards, after the sequential model, what we do is we add layers. That means the first layer will be hub.keras layer here, from where we can load models available in this tf-hub.dev. And what we are importing is universal sentence encoder. All right. So we will be loading this encoder here. Now, let's understand what we have done. We have added a layer called the dense layer here. Okay. Now, let's understand this hub.keras layer first. If you see, we have just used /4 here. It denotes the variant of the universal sentence encoder on hub. So here we are using deep averaging network variant. Okay. It has other variants also. It has the other variants like transformer architecture. Then we have the input shape. So since our data has no features, but the text itself, so their feature dimension is empty. If we provide array or some numerical data, then we can provide the dimensions here. Then D type is basically, since we'll be passing raw text itself to the model, so we have just mentioned the string part here. Now, trainable true denotes whether we want to fine tune use or not. So we set it to true. That means the embeddings present in the use are fine tuned based on our downstream task. So next we add, of course, the dense layer with single node to output the probability of clickbait between 0 and 1. And we have used the activation function sigmoid. Then if you can just see, this is another way, of doing it alternatively. So in this, we have implemented the exact above architecture using the TF-Keras function API. This model is also exactly doing the same thing that we have done above in these 4 lines. Okay. So after creating the model, let's see its summary. This is the summary. This is how it looks. Now, if you can see the total parameters, trainable parameters, that means all the parameters that has been created or passed are trainable, because we are fine tuning the universal sentence encoder. If we are not in fine tuning the universal sentence encoder, that means we have non-trainable parameters. Since we have set the training as true, so that means here the parameters would be trainable. All right. So since we are performing binary classification, we are just saying whether whether the sentence or the text has been taken from the clickbait or not. So it is kind of a binary classification task. So we are using a binary cross entropy loss along with the Adam optimizer and accuracy as the matrix. And if you want to use any other matrix to judge your classifier or to analyze your classifier, you can use that also. Finally, we'll fit this model. Here, we have just used 2 epochs because it takes hell lot of time. So just to show you that how much accuracy it can gain just after 2 epochs, you can just see here, the validation accuracy is 0.98, that means 98%. So just after 2 epochs, it is giving this. So you can just try for 3 or maybe 4 or 5, whatever. So this also has taken around like 30 minutes or so, 2 epochs. So if you want to try for some more, just be sure that you have nothing to do else. and you just have to wait it out. All right. So this is the accuracy that we have achieved. So finally, I have just kept this example for you to run it here. So I'm going to predict 2 lines or 2 pieces of text here, and let's see what kind of answer we get here. So first text is 21 pictures that will make you feel like you are 99 years old. And another one is Google announces TensorFlow 2.0. So let's see what our model predict. So, okay, it has just given the answer for the second part. So let's just, okay. Now let's see the output for this. See, it's favoring 99 for 1. That means it is from the clickbait. And let's see for this text. 0.004 for 1. That means is not favoring that it has been taken from clickbait. So it's a pretty good estimation, right? Let's get back to our slides then. So these are some recommended courses if you want to learn more about the transfer learning. But for that also, you must understand the deep learning part and the models that we already have, pre-trained models for these to understand. So these are the courses from Udemy, Coursera, and LinkedIn. And these are pretty good courses to have a good structured understanding of transfer learning. Finally, thank you. And if you've liked the video, please like, share, and subscribe to this Naukri Learning channel. Thank you very much.